Good morning, class. It's that time again. Time for another screencast tutorial. This week, as I mentioned on Tuesday, we are making the transition from QGIS to GIS. If you recall, there is that Unix Linux philosophy of making one tool to do a job and to make it do that job the best as possible. And the correlate is that you should use the tool that's best for the job that you want to do. Up to now, what we were trying to do was web mapping, some basic vector digitizing, thematic mapping, and cartography. And QGIS is definitely the tool for those jobs. From here on out, what we're going to do is some more analytical procedures. And while you can do many of the things that I'm going to show you today in QGIS, GIS, in my opinion, is the superior tool because of the way it manages the data, because of the way it manages projection information, and particularly in terms of the optimization of the routines. They often run much faster in GIS. On top of that, GIS has many more analytical tools available in it. If you are more comfortable working in QGIS, know that there is a way to draw the tools from GIS into QGIS and use them from within QGIS. Remember, they're sort of like brother and sister GIS tools, so that there is a cross-pollination between them. Your workflow eventually will include using QGIS for some things and GIS for other things, and you will find the line that's best for you in terms of when you want to switch from one to the other. The first thing that we have to do, though, when we switch to GIS is to realize that it imposes some requirements on us into the way that the data are going to be imported, managed, and dealt with. And I talked a little bit about that, this idea of a GIS database with locations that contain map sets. And probably the best way to demonstrate this is to just go through the procedure of setting up GIS for the first time with a brand new data set. All right? So on your computer, find wherever your little GIS icon is. In mine, I can go here and just get it, GIS 7. By the way, brand new version of GIS is 7.4, so that is the version that we are using today. The previous version, 7.2, will work just fine. There's a couple of small things that are different between them, but in general, the appearance will look very much the same. So you just click on it. First thing you'll notice that it will bring up also this little command line terminal. That might scare you at first, but know that you never have to use that if you don't want to. And in fact, on Windows, there are ways to start it up so that this doesn't even pop up. Okay? And then you'll see this window that says GIS bringing advanced geospatial technologies to the world. And likely then you'll see this red text and you'll just get scared. All right? So don't get scared. Basically, at this point, we don't have a GIS database. We don't have any GIS locations or anything like that. The first thing that you want to do is to point it to a directory on your computer that is going to be the place where all of your GIS data is going to live within. Much the way I showed you manually how to set up your data archive in QGIS, all we have to do is just set that first folder up and then GIS will take care of doing the rest. This is one of the main benefits of using GIS. So I'm going to make a new folder over here in my working directory, but I'm going to do it from within GIS. I'm just going to hit the Browse button, and I'm going to navigate on my computer to Working Directory. And at this point, I can actually make a new folder. In my system over here, I have a little thing that says Create Folder, and I can type the name of it. I'm going to call this GIS_database in all caps. You don't have to call it that. It just is a nice title that's pretty standard. The other sort of standard title from previous versions of GIS is GIS_data. Either way, it'll work just fine. You could name it My Data, you could name it whatever you wanted, but this is, again, we're using names that are meaningful to us. So now I'm in GIS data, I've selected it, I'm going to hit Open, and now I've got my path to that right here. So this is the entire pathway to that new database directory. It's still giving me this error saying, hey, there's no location, create a new one, or choose one that already exists. Okay? And there are a couple of things that we could do at this point. If we wanted to fool around with some great tutorial data sets, we can go to this nice new download button, and we could see all of these fantastic fully formed GIS locations. That might be the easiest way to get into it, but you may not be interested in any of these things. Now, if you're following along with the GIS book, or if you're following along with some other standard tutorials on the internet, you might need the North Carolina location, you might need the spearfish location, and you might want to get like the world long location, and then there's a few other newer sample data sets that you could download from here. We, on the other hand, are going to continue to work with our Kazakhstan Kurgans data set, but we're going to have to pull that into GRASS, so we're going to have to make a location. Now, up until this point, I told you, we were letting QGIS reproject things on the fly so that everything overlaid with each other. Most of the data were in unprojected latitude, longitude projection system. Some of it was in that pseudo-Mercator projection that Bing Maps or Google Earth uses, and one or two of them were probably in a UTM location. What we want to do, as I said, because we're going to do some analysis, we want to set up a UTM location. And the first thing we need to do is to figure out what zone we are in. So the easiest way to do it is to go into your little Google search box or whatever it is that you use and just search for UTM zones. I like image search. It gives you a whole bunch of these really great UTM zone maps over here. One of the ones I really like is this one at Wikimedia Commons. When you click on it, it opens up full screen and it gives you all the zones across. Remember, each band like this is a tangent to the Earth, meaning that the distance measurements are pretty accurate. The downside is that you have to stick within one of these zones. You can see here's our area in Kazakhstan where we've been working, and it's a little hard to see, but we are actually right on the border here between 43 and 44. Most of our project area is in 43, so we will use zone 43, and it is north of the equator, so we're going to use zone 43 north. So when we go back over here, we click new, and we get this fancy dancy little pop-up window. The first thing we want to do is to give a name. It says by default new location. Let's give it something more meaningful. So like SEKZ, so Southeast Kazakhstan, and then really important to put UTM Z43N, UTM zone 43N, and we're going to give it a WGS 84. Now, why did I put this whole strange string of numbers? Well, years from now, when I go looking through my GRASS locations, I will know for sure right off the bat that this is Southeast Kazakhstan. It's a UTM projection in zone 43 north with a datum of WGS 84. You can give it a location if you want, but you can give it a title if you want, but that's not very important. I typically just leave that blank. If you wanted to, you could type out Southeast Kazakhstan UTM or something like that, just to give yourself a more human readable extra bit of information. At this point we hit next and we get to a new page, and here we have multiple options. If we had a known piece of UTM zone 43 north data, we could read that projection information directly from the georeference file. So let's say we had a GeoTiff or something like that. We would select this. On the next page, we would then browse and try and find that piece of data, and GRASS would read the projection, the CRS projection information, directly from the tags inside that data. At this point, we don't really have one that we know for sure, so what we're going to have to do is to set it up from scratch. And there are a couple of different ways to do this. We could select the EPSG code if we knew off the top of our head what that was for 43 north, but we don't right now, so what we're going to do is to go down to Advanced Methods and click Select Coordinates Systems Parameters from a list. Then we will hit Next, and we will get this page. And down here we have basically every projection system you could imagine. But what we want to do is to click where it says Search in Description, and let's just type in UTM, and we'll hit Enter, and we get Universal Transverse Mercator. That's our general projection system. When we hit Next, it's going to ask us to put in the zone information. We can type here 43, and then basically it's not in the southern hemisphere, so no, right? Leave that no. If it was a southern hemisphere, if you were in Australia or something like that, you would select yes at that point. Of course, it would be a different UTM zone in that case. We hit Next, and now we have to search for our datum. And I told you we were going to do WGS 84. We hit Enter, and from that giant list of possible datums, we get one, and then we hit Next. Just leave this alone for now. We want to use the datum translations just so that Basically, we have it here. We have a summary of what our projection information is. This will be written to that special wind file or proj file that I told you about before. So we hit finish, and it says the location will be created in the database. You will need to change the default directory in GRASS startup screen. Click OK, and here we are. So remember, by default, it creates a permanent map set inside our new GRASS location. Permanent contains those special files that contain the region information by default and the projection information by default. You never want to delete permanent, right? You always want to leave permanent in there. We could create new ones, but at this point we're going to bring in our raw data, so we're going to stay working in permanent. Okay, we're just going to hit Start GRASS Session. You see the nice splash screen, which was new with GRASS 7, and you get these two windows popping up. So unlike QGIS, GRASS has a sort of windowed interface. You have the layer manager and you have the map display, and then also you have the terminal behind here that will stay up in the background. Okay, so basically these are your three kind of things that you're going to use. I'm going to hide my browser window behind there just so to make it cleaner for you to look at. We have no data at all in this particular thing, but here on this side, the layer manager is where you basically manage the layers of data. It's also where you get into the menus to do your different analyses. Over here you will display the data in both 2 and 3D views. This is another cool thing that GRASS can do that's not possible in QGIS. And you'll pan, zoom, move around, and a few other things with tools that exist up here. The very first thing that we need to do is to start importing our data sets. So I told you before that you need to make sure that all the data that's in a location in GRASS has to be in the right coordinate reference system. So before, the workflow was to import the data into whatever coordinate reference system it already existed in. So if it was lat long, we'd make a lat long location, import the data into lat long, go back out, create a UTM location in GRASS, then reproject the information from the latitude longitude location into the UTM location. That's worked perfectly fine. It was just a convoluted, kind of complicated workflow. With GRASS 7.2 and forward, that workflow has been simplified quite a bit, because now we can reproject upon import of the data from whatever it used to be into what we've set up here. All right, and basically we go to the File tool over here, and we have our import tools and we have our export tools. So we're just going to deal with our import tools over here. We're going to start by importing raster data, and here we'll just pick the simplified raster import with reprojection. If our data was already in this particular UTM zone, then we could just pick the second one down here, which is just import common raster formats. But we want to reproject, so we'll click r.import. And I just want to point out that all the tools have the sort of common language or English language names that say simplified raster import with reprojection, and then the GRASS name, which is r.import, r.inxyz. And you go to any menu item, they all have that R3 to rast. You have I group, I target, you have V edit, V type, V extract, right? So R for rasters, V for vectors, I for imagery, D for database, and then you have the G for general tools over here. And some of them exist in multiple different menus, but eventually, once you know the name of the tool, you can just type it on the command line and get it to go. But that's a little bit more advanced. We're going to just stick by going to the menus and clicking the buttons. And here we have our import thing. And basically, all we have to do is to browse on our computer. And I know exactly where mine is, working directory, Talgar, GIS data, raster, because I was organized before, right? And the first thing I'm going to do is to bring in my Landsat 8 natural color. .tiff, and then we're just going to hit open, and at this point we're pretty much ready to go. We could go to this, so there's tabs down here, source settings and import settings. We can tweak a few things over here, including the resampling method for reprojection. By default it uses nearest neighbor. That's pretty good for images. For DEMs we would probably want to use something else. We can also use Lanczos. Takes a little bit more effort out of your computer. The raster map extent, we'll just leave it to input. The resolution we could put in directly if we knew it. We could put estimated. We could put value, and if we put value, I know in this case it's actually, 15 meters or something like that. But we're just going to leave estimated for now, and we could do a couple other things over here. Now, kind of important on this tab, go down to optional and click this do not perform region cropping optimization, because we set up a blank location. The region, remember, is the little box, the sort of window onto the world. By default, it sets it to 1 pixel down in the bottom left corner. And you'll try to import your map, and it'll show up blank, and you'll be like, where did my map go? Well, it cropped to the region, but the region was way outside the zone where the map was. So we'll just click this box here to save us some frustrations. And then we'll go back over here to the Source Settings tab. We'll hit Import, and it will run through. There we go. Now we actually see our map that we are dealing with. Right now, before I import any other pieces of data, what I will do is just set my region to match this. We will still override the region cropping because we want to bring the whole extent of all the data. But this particular view is a really nice view to set our region up. I did that for you already, so we'll just go back to our layer manager. We'll click down here where it says layers. By the way, you noticed it said when it ran, you got this console that popped up. This just shows you what it's doing. So you go back to layers, you right click over here, click, and then select set computational region from selected maps. We'll click OK. And now, if we happen to forget to reset our computational region, it'll just clip to this area, and that'll be fine for us for now. So what we're going to do now is go back to our import data. We're going to browse. We're going to select our Tiffs that are our SRTM Tiffs, and we're just going to import them one by one. Projection of the layers were projected. Import and reproject. That should be fine. Okay. Reprojecting. It's doing its thing over here. We will grab the other one. We will import that one. Import and reproject. We'll just wait for it. We will grab the third one over here. Import and reproject. So it's saying import and reproject because these ones are actually in latitude longitude projection system, whereas our Landsat was actually already in the UTM zone. All right. So now you're saying, what happened to them? Why are they all stacked up on top of each other? Well, remember, we have, every time we import, it sort of is zooming to this thing. So if we go back into here, we can click up here into some of our zoom and pan controls. We click this one that says various zoom options. We can hit, we could potentially, oh, we didn't save a default region, but we could have set that right here. Instead, what we're going to do is to go back to this one, right click on it and say zoom to selected map. And now, remember, our layer manager works the same way as it does in QGIS. Whatever's on top is on top, whatever's on bottom is on bottom. The checkboxes display and not display it, right? So now, there we go. We can actually see what we've got. If we zoom out, I'm just using my mouse wheel to zoom out, we can see we actually imported all of them. Didn't crop to the region we set before, but we could have cropped to that particular region. That's all of our raster data. I'm going to close that and go back up here, and I'm going to introduce our vector data. So I'm going to go to import vector data, simplified vector import with reprojection. Let's go ahead and do that. Same deal over here. We're going to go to our optional, we are going to go to our browse. We're going to go to documents, go to my Talgar GIS data, find my vectors, and I am going to bring in first the survey units, and you want to click where it says .shp. That's the one you want to click on, not any of the other ones. Otherwise, it won't really find the whole file, because remember, shape files are strange. They come all together like that. We click OK. If we go to the import settings, we'll just leave everything the same. GRASS doesn't clip vectors to regions the way it does with rasters. So at this point, we're ready to just hit import, says the same deal, doesn't match. Do you want to reproject? We're going to do that. So there we go. And we're going to pick our streams file for now. And again, we're going to click right on where it says .shp. Click open and import. And then we'll see the streams are in there. And then the last one that I'm going to import today is the Kurgans that I digitized. So I'm going to click the SHP file, click import, import and reproject, and then there we go. All of my little Kurgans that I managed to digitize before in QGIS. I'm going to hit close. And I'm going to go here, and I'm going to zoom back. I'm going to zoom back out to my Landsat image, zoom to selected maps so I can see the whole area over here. And in fact, what I could do is I could use these zoom tools to zoom out over here. I can use my pan tool to move things around. And also now I have a really cool query tool. Whatever map I happen to have selected over here, wherever I click on the map, a little box will pop up and it'll tell me. In this case, it's just telling me the color value because I have the Landsat map. If I had the streams map and I try to click on a stream, it will tell me information about the particular stream. If I have survey units and I click on a survey unit, it would tell me information about this particular survey unit. And again, remember, I can hide and show any layer I want just by clicking and unclicking over here. And if I clicked on my SRTM, if I make sure I click the right one, it would show me information. It happens to be this middle one right here. It would show me the value in this case, which is the actual elevation of the file. So basically, we're pretty cool right now. We've got all of our data into GRASS, and we're ready to do some analyses. We're dealing with overlay operations for this week, so I'm just going to go through a few basic overlay operations, mostly with the vectors, but we're going to start first with patching our SRTM files. Now you see, when we reprojected, there was a few mismatches over here. Probably the better way to do this would have been to have imported these three rasters into a latitude-longitude GRASS location, patched them there, and then reprojected them all as one. If we patch now, there's going to be a few holes in this, but to save a little bit of time, I'm going to do it the quick and dirty way, which is just to patch them now the way we have it. So basically what we're going to do is we're going to get into these menus over here. Feel free to explore all of these menus, by the way. There's all kinds of really cool things, and we will definitely use some of this stuff in later practicums in our class. But the first deal that we want to do right now is to find the one that says overlay rasters and R patch. This is a basic overlay. Whatever maps that we enter, they're going to patch them together in the order that we give them, just the way the layers that we have. If they're side by side, they'll just be a seamless image. If they're overlap, whatever's on top is going to be imprinted onto whatever's on bottom. It's going to make a brand new raster file. So we'll click it R patch, and we'll get a new little module that pops up. Every tool in GRASS has a module that pops up. It has its own options, and what's really cool, it has its own little manual page. So if we do that, I just expanded it, we get help for all of them. It explains what exactly is going on. Very often it gives you some notes and some examples about how to use it. So very, very, very helpful. The manual pages and all the modules in GRASS. Okay. Here we have a required tab, an optional tab, and sometimes we have other tabs in here that we will set options for. And essentially what we're going to do is we're going to pick our raster files. And again, the order kind of matters because whatever is on first in the list will be what's on top in the patch. For these particular ones, they're side by side, so it doesn't really matter, but we'll just pick them one by one. Essentially what we're going to do is to pick, let's see, we have 70. So first we're going to just delete because we want to start with 76, and then we'll pick 77, and then we'll pick 78. And the resulting map, we'll give it a descriptive name, patched _ SRTM 30 meters. Now remember, no spaces, no dashes, and try not to start with a number, particularly for vector files. Don't start with a number. It won't let you start with a number. And at this point, we're good to go. We can just hit run. Now, something interesting is going to happen when this goes, right? We've just patched our SRTM, and I'll bring it up here to the top. And if we unselect our full SRTMs, we will see that it has been clipped. And you're going to ask yourself, why did GRASS do that? It clipped it to the computational region, which we set before to match our Landsat image. So now our SRTM perfectly matches the boundaries of our Landsat. We don't have any overlap that we have with our original images. You may not want that. You could expand the computational region to match, for example, the current view over here. So if we go back, we display all of these things, and then we draw a zoom box, something like, well, let's zoom in a little tighter, something like this, and sort of center it like so. We could go up to this menu item and say set computational region extent from display. We go back to our R-patch tool over here. In the optional panel, we're going to click allow output files to overwrite existing. That way, it's going to write over this. If we don't click this, it won't write that. We'd have to give it a new name for our new raster map over here. We hit run. We will see that it will take a little bit longer because it's a bigger area that it's doing the patch operation in. And now we have the patch look just like this, right? And our Landsat is smaller. So it's up to you to decide what you want to do. Probably for us, for right now, we're just going to select our computational region to match this. We could also go up to Settings, Computational Region, and Set Region to get a G region tool over here. And we could set it right here, Set Region, to match a particular raster map. So I could pick my LS right here. And what's really cool is we can also now set the resolution of the raster. So this particular raster is 15 meters. Our SRTM is 30 meters. So we might choose 15 meters, we might choose 30 meters, depending on what we're doing. For right now, we want to set it to actually be 30 meters because that's our elevation data. So we're going to do that right now. We're going to hit run. Whoops, what did I do? I put it in the wrong tab. It should be in the resolution tab. The 2D grid resolution should be 30 meters. And we can also hit this print the current region, and it will just print out some information over here, confirming to us the boundaries, north, south, east, west, and that the resolution is pretty much 30 meters. Okay? So at this point, one thing that we could also do is, let's see, I always forget what tab it is. Yeah, on the existing, we can put save as the default region. We'll hit run. And now every time we start GRASS back up in this location, by default, it will take us to this particular region. If we want to go zoom back to default region like I showed you before, we can do that. Okay, we can hit this again because no sense having extra data floating around if we don't have to do that. And over here, I'm just going to hit my shift key, select all of these things, and then I'm going to right click remove. I'm not deleting these, I'm just removing them from the layer manager over here. We have our patched SRTM and our Landsat. And now we can zoom to default region and we zoom right back in. Okay, so that's our first overlay, patching raster maps together. Let's do our first statistical overlay, and let's do it with our survey units right here. We'll go up to vector and we'll try and count how many of these kurgans are in our little survey area. So we will go to vector and we will go to, let's see, I always have to remember, when I haven't done this for a while, I have to remember exactly where things are. And I think it's actually reports and statistics, and, or maybe it's query. You're going to be doing this a lot. Now, overlay, point analysis, query feature selections, select by develop. Give me a pause for just 1 second while I totally remember exactly. Okay, while I was paused, my brain started working again, and I remembered exactly what I was going to do. Okay, what we want to do is to query one vector with another vector. And to do that, what we want to do is to go down to where it says update attributes. So what that means is that before we do that, we can just look. We can right-click on survey units and go to show attribute data. And this is the table, right? So this shows us that we have our basic columns, right? We have a new one called cat, which should be kind of similar to ID, a unique identifier that GRASS makes by itself. We have unit number. We have location, surveyor, and that's basically it at this particular point. So what we're going to do is to query this so that GRASS will make a new column and upload a count. Okay, so we go to vector, update attributes, and we'll find this one that says vvect stats, update area attributes from vector. We get our tab over here. The first one says required, the input vector map points, right? So this is our Kurgan points right here. Selection. We have another name of input map, areas. This is our survey units over here. And we could put a few other little pieces of information in here, but we should be fine at this particular point. We want to just count all the points. We don't need to narrow this down with an SQL statement for particular points or anything like that. But if we wanted to, we could build an SQL statement that said only count mounded Kurgans, right, where it has M in the Kurgan type, K-type column in the points file, or only count ringed Kurgans or something like that. It's a little advanced, so we're going to skip over that for now. And this particular point over here, we're going to go to the optional tab, go to where it says method for aggregate statistics. You can do a bunch of stuff in here, but particularly what we're going to do is, well, we'll just go to sum over here, and we could get some statistics from the column if we wanted to, but we don't need to do this. We're just going to put column name over here, which is called count. And actually, we didn't need to do sum. I'm getting ahead of the game. We just want to put count over here, and we should have this over here. We go back over here. We hit refresh, and we should have had. We probably had to make the new column first. So let's go to manage tables, column, count, integer, add. Back over here, we have a blank count column over here. And there we go, 22 in Professor Ula. So basically what we have here is 22 Kurgans inside my particular survey square. So I'm going a little bit faster this. We can talk about this in class, but that's our very first overlay, statistical overlay counting. We could have done some other kinds of summary statistics. For example, calculated the average diameter of each Kurgan in there. But we're going to run forward just a little bit because I want to show you some buffers, and we're running out of time. I don't want to make this tutorial too long for you to watch. So what we're going to do now is just create some buffers around our Kurgans over here. Right now the style of the points is little X's. I'm going to make it a little easier for you to view. I'm going to go to, well, basically properties, just like in QGIS, and I'll go down to symbols, and I'll turn this to little squares, and I'll go to colors, and I'll change it to just little red filled colors like that. Little red filled circles just so you can see my Kurgans over here. And click OK on that. And now we can calculate buffers, and we can basically make new vector buffers. So we go to vector, we go to vbuffer, buffer vectors over here, and we're going to make a new output vector map. So we'll put Kurgans, and in this particular case, the first one we're just going to do is 40 m buff. Okay, we're just going to do a basic 40-meter buffer all the same. So we're going to go to the distance tab. We'll hit buffer distance along major axis and map unit, 40. All right, we can make them oblong by doing a minor axis, but we'll just leave that alone for now. And we'll hit run at this particular point, and now we will see buffers created, right? Buffers created, all 40 meters. If I go up to my little measure distance tab, and I zoom in on the map, and I measure across like that, we will basically see the segment total is, well, pretty close to, 40 meters is the radius, right? So it should be close to 80 meters diameter. And that's basically what we did, as close as my measurement could be, 79.48. Okay, so we'll just get rid of that, get rid of our query window. So that's all right. Okay, so now we just have 40 meters around. And what we can do is to upload the, well, actually what we can do right now first is to figure out a different way to buffer the vectors. So this is just a standard buffer of 40 meters, something like that. We could go out 100 meters, and we would just make different buffer sizes over here. We could do a couple of different things. We could transfer the attributes from the points, which is a pretty useful thing to do, so that the table associated with the buffers is the same. So we'll just do that. And now what we have is our buffers, which are over here. We can go to our attribute data, and we'll have the same columns that we had before. So that's kind of useful to do. Maybe we want to actually buffer these things to the right distance, right, to the exact distance of the diameter that they really are in the real world. So what we'll do is I'll go back up here, and I will put Kurgan's diam buffer. All right, so that's basically another little naming convention to help me remember what this particular map is. And instead of 40, I'm going to delete that. I'm going to go down here to the column for buffer distances, and I will type in k underscore size, right? K underscore size. And we need a scaling value because our k size is actually the diameter. We want to turn it into a radius. So I'm going to change this to 0.5, all right, just to divide it by half. And we're going to hit run. Buff call option requires a valid layer. What did I do wrong? Selection, instead of -1, we have to select layer 1, which will get us the attribute values over here. And we'll go back over here. And now we have a list of the columns in here, k underscore size. I'll just go back real quick and explain what I did. Layer -1 is essentially just the geometry of the vector file. Layer 1 is the geometry plus the table. And we could have more tables associated with the layer if we wanted, and they would have 2, 3, 4. All right? It's a little bit confusing, but just keep in your head, if I want to get columns out of the table, select layer 1, and then I can select my columns from the attribute table. At this point, we can now hit run. It will do it. We will see the new vector file, so I'm just going to hide the old one. And if we zoom in a little bit, we can actually see all the buffers are different sizes. In fact, these are the real sizes of the Kurgans as they exist in the real world, at least as you measured on the map. Sorry, I meant to show our Landsat. All right. So that is pretty cool. We've just created our first buffer map, and now what we want to do is to upload some information into our table. We're going to do two things right now. What we're going to do is first sample at the actual X and Y location of the point that you clicked when you were digitizing. We're going to sample the elevation file and bring that into the table of the vector points file, the Kurgan points file. To do that, we'll go back to vector, and we will go to update attributes. We will go to update point attributes from rasters, v what rast. So we click that right here, and then we have our points file. Because I have it selected over here, it automatically populates it. You can always click here and select it, Professor Ulla Kurgans. And then name of existing raster map, we will pick our patched SRTM. We have a few other things. We could interpolate from the nearest 4 cells so that we get a little bit of an averaging. But basically, we're just going to leave everything pretty much the same over here. Name of attribute column to be updated with query results. We will just put LEV over here. Now, we may have to make that column, but let me just see what happens when I hit run. And then we go back here and we look at our attribute data. Now, in previous versions of GRASS, you used to have to make that column first, but now it makes it on the fly. And basically, we have the elevation taken from our SRTM at exactly the point where we clicked the map before, and it's automatically uploaded into our table, which is pretty cool. We want to do the same thing, but we want to do it now, getting an average elevation inside the actual Kurgan. So we created our buffer that's the same size as the diameter of our Kurgan, and now we want to find the average elevation from the SRTM across that. And this is important because while points will fall within one raster cell or another raster cell, a polygon may cross borders, all right? So if I go over here, it may cross some borders, and we're going to want to upload that information into our cell as an average across those two or three or 4 cells that perhaps this particular small polygon crosses. So we'll just go back to update attributes, and we are going to do sample, let's see, update area attributes from raster, vrast stats. And right now we have to go in here and select our diameter buffer, and input raster map will be our patched SRTM, and it's going to give us some statistics, so we'll give it a prefix here. We'll just put LEV as our prefix. It'll make a bunch of columns because it's going to give us some statistics, okay? We could choose all of the different statistics that we wanted to. At this particular point, I'm going to uncheck most of these things, but I'm going to keep essentially min, max, average, and standard deviation. I'm going to hit run. And now we can go back over here and we can view our attribute table, and we'll see a bunch of new columns that are added: LEV min, LEV max, LEV average. And for most of these things, because they're so small, this is going to be the same. All right. Now, on the other hand, if we did it with our 40-meter buffer, we are going to cross some 30-meter SRTM cells. So probably we're going to see some variation if we did it on that one. So let's try that. Let's go back to here. We'll just change this to our 40-meter buffer. And we'll hit run over here. And we will now look at our attribute table for that. We will see the same columns, but now we're actually seeing some variation. The minimum and the maximum are different because we're definitely crossing over some raster cells, okay? We have one last sort of thing to do in this sort of genre of stuff, which is to find the distance to the nearest feature. And we're going to find the distance from our Kurgan as the crow flies to the nearest stream, okay? And to do that, we're going to find v distance, and I have to remember specifically where v distance exists. So as before, what I'm going to do is to pause the video real quick so I can reorient my brain and tell you the right thing. Okay, as with most things, it was sitting right in front of me. It's actually right here. Nearest features v.distance. So I'm going to click that and it will pop up hopefully in just a second. Now, what I should show you is, give me 1 second. So I had a little bit of a crash on my GRASS because I was trying to do too much. So I'm back kind of a little bit at square one. I just restarted everything. I'll show you. I just realized I didn't show you how to add layers to the layer manager over here. Basically, we have our little add tools right here. Add raster map layer. Here I'm just going to add our patched SRTM. I can click OK over here. And I'm going to add our, I'm going to add vector right here. I'm going to add our streams. There we go. Click OK. And I'm going to add our points, our Kurgan points, like so. I'm going to go back to my properties, and I'm going to reset my colors and my symbol so that it matches what we were doing before. There we go. And I could do the same thing with my streams over here, just to make them look more stream-like. I can make them blue. Okay, like that. And right now, by the default, the color scheme for the raster is this viridis. If I wanted to, I could change the colors here, set color table, and I could go to define. I can pick any number of color tables I wanted to, and it would change the colors behind it. Hexby is a little bright for my current thing. Usually the one that's default viridis is a good color scheme, so I'm going to set it back to that over here. Okay. And so now we're basically where we needed to be before. We go to vector. It was right in front of me. Where is it? Nearest features, v distance. And I should show you that there's also on the tab over here called modules, a little file tree, and you can click it and you can get all of the stuff in this sort of tree format over here. And then you can do a little search for v.distance, for example, if you know the name of it, and it will find it for you automatically. So if you're forgetful like me and where things are specifically, and you've written down v.distance, you can always search for it here in the modules command window. Okay? So here we are. From and to. And again, remember there's manuals for all of these things. You can always look up information about it. From and to. So from, we want to pick our points map, Professor Ulla Kurgans. And we're just going to tell it, just make sure that it is points right here. Column name of nearest feature used to upload to attribute. We will put nearest strum. And I may have to make this column, but let's just see what it does. And then, sorry, whoops. I should have been in the from column. Should be from the Professor Ulla Kurgans, and we want to make that one be point, and values describing the relation between the two nearest feature, minimum distance, and then we could pick X or Y direction or other things like that. Okay, and then to, we need to pick streams, and instead of point, we want to make sure this is a line. This is kind of important, just to make sure you're telling it the right thing. Nearest stream. And I think that's what I want, maybe not nearest Kurgan, but let's hit run and see what happens. Column requires at least one. Well, let's just see what it does like this. To, from, upload, column, where values. Oh, this is where I should have put the column value in. Nearest strim, okay? And it doesn't exist, so that means I have to add it. So here we're going to go back to our Professor Ulla Kurgans, go back to our attribute data, manage tables, add column, nearest strim, and instead of integer, I'm going to click double, which means I'll get some decimal points. I will hit add, and then now it's blank over here. When I hit run, and I hit refresh, now I have the distance, right? I have a distance to the nearest particular stream. What I could have done is gone to optional and created a new vector output map that would create lines to these things. So let's type kurgs to streams. Remember, no dashes. That should have been a underscore right there. Okay? And we could put a few other things here, but let's just hit run. And now we have the lines, right, connecting them right here. What I could have done is to also put, well, I could have put the category number. So I'm going to go back to optional, and I'm just going to select allow overwrite, just so I can overwrite these things. And not enough column names, right? So now what I need to do is to add a new column that says streams cats, stream categories. Turn this back to an integer, hit add, and then over here I need to put in streams cats, right? Streams cats, the same thing with a comma between them. Hit run, and now I have the category numbers also, as well as the values for that. In fact, what I needed to do is to put these the other way around. You'll see it has to go in the same order that they're listed over here. So stream cats, and then nearest stream. And now when we hit run and hit refresh, we have the category number over here and the actual distance in the right category right there. So that is enough for now. I'm going to upload this to YouTube, and hopefully you will see it in just a second. See you in about an hour.